This is we're going to show some of the components. A component in TradingView is just an indicator because TradingView only knows of indicators and strategies, but we call them components because they go between your regular indicators and the strategy. And they allow you to mix and match the indicators in ways that would normally require programming, but now you can just drag and drop and connect. So here's an example. Here we have a price latch, and what it's doing is it's picking up these prices from this indicator here, right? So it doesn't matter what the indicator is, just one of those high, low things. And you can see it's showing you kind of how these things are joined up. And we're going to have a look at one of these price latches. And as you can see, it's picking prices. So it's picking that price there and then that price there. If you're wondering why it's two after, it's because these are pivots. So even though it's showing the pivot there, the pivot actually isn't identified by TradingView until here, until 2 bars after, because the internals of this are set to look for 2 bars on the left and right, see? So even though the label's pushed back to the actual signals detected here, because you can't have a pivot without both sides. So that's why this line looks a little bit behind here. It's because well, it is. It's not actually behind. It's actually this has been pushed back the wrong way. I mean, back the other direction. So that all said, this line's following these. And now the question is, what is it following? Well, let's see what price latch is picking up. Well, it's not actually picking up fusion pivots. It's picking up our and/or router, but it's picking up output 4. So let's go to the and/or router and go to output 4. And we have several outputs because we probably want to use it more than once. Okay, so this is picking up 5, 6, 7, 8, and 10. Okay, so let's see what 8 and 10 are. Here are inputs. 8 is the high-low of the pivot. And 10 is the low-low. So, and then if we go back to 4 again, because I've got to check, it's an OR function. So either this or this is true, then get an output. So basically, price latch is picking up 2 of these signals, and so it's either the high-low or the low-low, and it's picking up those signals. And when one of those things go, it's latching in a price. But what price is it latching? It's latching the low, the candle, right? So you can latch whatever you want, obviously. So it's latching the low, the candle, and it's using these. And we're not doing anything for exit signals, but obviously you could do an exit signal as well. So that's an example of using the and/or signal router and the price latching router. Sorry, router, the price latch. Now, you might be wondering, why is there an A and a B? Well, in this case, the B is just using the other side, right? So it's just picking up the high highs and the low highs instead of the other side. But the reason we have the code is identical. There's absolutely nothing different between the code. However, down in our strategy tester, Nexus, we got to pick those signals up. And when we pick those signals up, we're actually not using them here. But if we were using them, they were used here as initial stop points, but I think this strategy actually decided to do it a different way. But if we were to pick them up, how would we know which is which, right? If you had both are just called price latch, it'd be difficult to know what's what. So I've started the process because TradingView doesn't have a way of, when you put more than one indicator of the same name up, to tell you which is which. So I've started the process of just creating 2 or 3 indicators with a slightly different names, just A, B, C or something on the end, so that you know that, okay, I know that A is doing this and B is doing that. It just makes life a little easier. I haven't done it with all of the indicators, all of the components, because some are a lot more common than others, and there's a lot. So kind of as the need arises, I'll kind of make that addition. And I'm hoping not have to do it for all of them, because I'm hoping TradingView will somewhere down the line get their act together and I don't know, automatically put an A and a B and a C on the end or something, so that when you come up here, you can see a difference. I'm hoping they'll do that one day. They haven't got there yet, but we'll see. Anyway, that's the and/or signal router. That has a couple of more aspects to it. I'll show. Actually, no, I'll show it now. Here are a couple of interesting things about the and/or signal router that I didn't show initially. These 10 inputs, so you can have up to 10 inputs. You select which of these channels, and I think there's 5 channels. Is it times 5? Yeah, times 5. There's 5 channels. And each channel you can say, I want to pull in these things, right? And any of these inputs. So you know what you put on each input, and you just select them. Like 1 and 2 is selected here. There is actually nothing coming on 1 and 2, so this is leftover from something else that's not being used. However, this is a good example to show you what you can do. You can AND these together, you can OR them, and then you can do the NAND or the NOR. Now, if you've done electronics, you'll know exactly what that is, especially digital electronics. But for anyone who doesn't, the N on the front is short for the word not, and not is just a way of saying to invert the signal. So if we'd normally put out, yes, there's something here, then I'll just reverse it and say no, and vice versa. So and or NAND NOR reverse outputs for these two. But also, what if you've had a whole bunch of us? What if you had 4 or 5 inputs coming in here? But let's say number 3, you want it in the other direction. You wanted to reverse it. Well, then if you can go down here and say, just invert that one. And so now it'll take the input and flip it instead of the output for the whole gate. It's just the input. And I use the word gate from electronics because I think of these and/ors and and/nors as gates. And in fact, I should show that to people because I think if you ever want to know what's going on, especially with the NAND and the NORs, and you're not so sure, NAND, NOR, and or images, gates, that should be enough. And I'll use Bing. Not a fan of Bing. I'm not a fan of Microsoft at all, but their image search is considerably better. I think the DuckDuckGo uses it too, so I could use either one. But for this case, it's just a little nicer because you can pull something up and make it full size, and you can't really do that in Google image search. So here's a picture. Ignore the exclusive or exclusive NORs. They're a special case which we'll probably we don't have, and we're not going to try and make. The chances of needing that's very, very rare. But here's the symbols for the and/ors and the NAND and the NORs. And the thing to remember is you can always take the output of any of these gates, like for example, this OR gate, and you can flip that and make it the input to one side of these AND gates. It's got a straight back, it's AND. It's got a curved back, it's an or front input side, whatever you want to call it. So, and it's got that double thing, that's the exclusive OR. There's another name for exclusive OR, but I never used it when I was doing electronics, so I can't remember what it was, what the other alternative is. But anyway, this idea of taking the output of one of these and route it into the input of another one, just so you know, you can build essentially an entire computer, your whole PC, phone, etc., at least the digital part of it, just by wiring these gates together in different ways. That's right. That if there's a theoretical framework that everything can be built off and or and not. Actually, I think it would just be an and a not, or an or and a not, and you can get the other one, the and or the or as well. It's been so long, I may not remember that exactly, but anyone who's interested, go for it. Anyway, this idea of putting gates into, the output of one to the input of the other is how you build up complex structures and very complex ways of doing things. And because of that, if we go back to here, we have that capability. So you can see we have all the inputs here, 1 to 10. But here on output, or look at output 2, but that's fine instead of output 1. You see we can have outputs 1 through 5, and 2 is ignored because we're not going to wire it back to itself, right? that could cause problems. But we can have the output of any of the other 4 channels as one of the inputs to whatever we choose this to be. And that allows you to build up very complex structures. You could say, I want this or this or this, but I want all that going into an AND gate because I only care about all that if this other thing, like a moving average, is certain height or something, whatever it is you're doing, right? So this allows you to build up very complex ways of putting together things. I think that's about it. So just keep in mind you can invert both inputs and outputs, and you can take outputs from these and wire them into inputs. And in the picture, you noticed it only showed 2 inputs, but obviously we can have all of these inputs going into a gate. So, and excuse my terminology, I use the word gate just because I started off in electronics, and so that's kind of where my brain is. I'm sure there's other words you could use for it, but that's how I remember them. But keep that in mind. This is probably the main component that you'll use out of everything. Is this and/or signal router. And up here is an explanation a little bit. If you forget, you can have a look through here and see how things are done. Hopefully that'll tell you in a much more concise version than what I just showed you. And yeah, I think that's about it. Let's see, did I go through the price latch? I think I did go through the price latch. So I think that's the whole thing. Thank you.